Hi, this is Maxine Spencer's presentation for, I don't know why I started in third person, that was weird. I'm Maxine Spencer and this is my presentation for Lab 3, which is black holes and whatnot. Anyway, so we want to be able to use GlowScript to model a black hole. That's more so for part one, and then just generally for gravitational pull. And we want to also, I don't know why this isn't stuff I wrote down. It's also to look at the difference between FNet when calculated as the parallel part plus the perpendicular part, as well as FNet when looked at as dp by dt, or change in momentum over time. Anyway, these are related to Newton's law of universal gravitation. So principles that we're looking at here, FNet is dp by dt, but FNet is also FNet parallel plus FNet perpendicular. So the lab kind of explores how, despite how they're calculated the same, applications are different due to how each version is calculated. And then of course, force of gravity is negative g times mass 1 times mass 2 divided by radius squared, and then times the radius. So of course, always a negative number. Yeah. So that's for after I look at the thing. So Lab 3 part 1, this is my code. Sorry, I'll get to the part that I actually worked on. So that's my planet's mass and whatnot. And then this is my little calculation loop. This is where it prints out the mass of the black hole, etc. Okay. Yeah, so that's that. And so if we run the program, this is what it looks like. So depending on the part of the calculation, it's generally about, it's between 1 and 9 times 10 to the 43 or the 44. So very, very high mass. Potential error with this, the weight that I chose for my planet, a little low. And then there's also, of course, just, you kind of have to eyeball these things, so obviously that can lead to human error as well. Anyway, for part 2, this is my lab part 2. I'm just gonna scroll through that. And now I'll run this. So this is my orbital speed and my orbital period. And then, yeah, took 700 hours, very interesting orbit there. Once again, don't know that that's how interesting it should look, but that's how it looks. So anyway, the process for each of these, obviously part 1 was about finding the mass of a black hole given all the factors of this, by looking at the change in momentum over time and using that as the calculation for net force, or at least that is how I did it. So then the second one was more about, using doing the relative gravity pull and whatnot. Anyway, kind of got lost in my train of thought there, my bad. So what does it mean and the what if? So, well, they are similar, FNet and dp/dt are different. That's not how I should have written that. What I mean is their applications are kind of different because FNet, when you're looking at that objectively, accounts for all of the forces in the system. Well, dp/dt is just, you know, velocity times mass, and then over time, you know, momentum over time. So it's much better to be used for more of an estimation, which is obviously the context in which we're using this. Then if I wanted to predict motion for the entire system, I would need to include like the mass and the gravity, not the gravity, just like the mass and like the net force with like any other like orbiting masses in the system, even though obviously they wouldn't have as much of a pull as the black hole because black holes have a lot of force. All right, that is everything for my lab. Thank you.